My name is Jantien Stoter, and on behalf of Geonovum, I would like to welcome you to this first 3D Bug developers meeting. And on the start slide, the first slide, you see other organizations. So they are the Netherlands Enterprise Agency, the Kadaster, the National Institute for Public Health and the Environment, het Waterschapshuis, and both the cities of Amsterdam and Utrecht. And in a few minutes, I will explain you more about their role for the 3D Bug. This developers meeting is organized by the 3D Bug team. The 3D Bug team contains the following members. So first is Ballas Tukay and Ravi Peters from the company 3DDI. They started the development of 3D Bug in our research group, and now they have their own company. And other 3D Bug team members are Hugo Ledoux, Ivan Paden, and Gina Stavrapoulou. And they will organize the meeting. But first, I will give you a short introduction to the 3D Bug and this meeting, and I will end with an overview of the meeting. First, start with some house rules. So as you already noticed, the meeting is being recorded. So I hope you agree, and you can also mute yourself or make yourself invisible if you want. And yeah, we also would like to make an interactive session as much as possible. Of course, this is very difficult with so many people. Therefore, we invite you to submit your questions in the chat, and then we can answer them during the Q&A sessions or later on. And I also would like to inform you about feedback sessions that we will have during the event this afternoon. And for that, you need a browser or your phone, so please keep them ready. First, I would like to give you a short introduction to the 3D Bug and maybe start with the abbreviation BAG, because in the Netherlands, everybody knows what a BAG is, but maybe not outside. So BAG stands for Basis, Registratie, Adressen en Gebouwen. That's Dutch. Translated into English, it's base register, addresses and buildings. And this is a data set containing footprints of all the buildings in the Netherlands. And the data set is collected and maintained by Dutch municipalities according to a common data model. And each footprint contains also information on the building, like the year of construction and the function of the building. And the 3D Bug is the 3D version of this 2D data set. The 3D Bug is reconstructed from those Bug footprints in combination with LiDAR point cloud that is available for the whole of the Netherlands. The 3D Bug is available also as open data. And if you would like to know more about the reconstruction process, I would like to refer you to the paper that is listed on the slide. But besides this data itself that we reconstruct for the 3D Bug, an important part is, of course, the software behind the data set and the hardware that makes the 3D Bug possible, so the processing and the hardware to make the 3D Bug available for the wide public. Currently, the 3D Bug is built and being maintained by a collaboration between 3DDI and the research group in Delft. The 3D Bug is available via the 3dbug.nl website. It contains some viewers so that you can inspect the data. But in this website, you can also download the data at different levels of detail and in different formats, OpenGIS formats. And the website also contains documentation. I would like to give you a brief overview on the development of the 3D Bug, also to understand the current status of the 3D Bug. So it started in several research projects that we had in Delft. And one of the main research funding that we got was from the European Research Council. And the aim was to have a testbed for 3D information. Firstly, to have a testbed to push the state of the art of 3D building reconstruction. But another aim of this testbed that we wanted to push 3D innovations in urban applications. So to have 3D city models available for to advance other applications. And for example, the research that we were involved in are on using 3D city models for noise simulation, for computational fluid dynamics used for wind flow simulation and heat stress simulations. And also we use the 3D city models reconstructed by the 3D Bach for energy consumption calculation. And another aim of this testbed was to push the use of open data standards like CityJSON, which is a standard for 3D city models that was developed in our group. And you will hear more about this later in this event. And so the CityJSON standard is also adapted as an OGC standard. With the research that we did in our group, we managed to have a first nationwide version of the 3D Bach available in 2021. And since then, we have several releases per year. And it's good to note that it never released, it makes use of a newer version of the source data, so it's more up to date. But also with every new release, we learn about from the process, from the reconstruction process. So if you apply it to all the buildings in the Netherlands, there are always exceptions that you do not encounter for at the start. Every new release also contains improvements and also new features that are the result from research that we continually do on the 3D Bach. For example, in the recent years, we added the volume of the 3D buildings, the areas of the wall, the roof, and the floor surfaces, the number of floors, and we identify party walls. And this is important to discriminate between outdoor and indoor walls, neighboring walls, and this is important, for example, for heat loss calculations. Currently, we have lots of other research going on the 3D Bach. For example, the addition of openings detected from oblique images, the use of other data sources than LiDAR point clouds, for example, point clouds generated from images, and the use of 3D Bach in BIM. Currently, the 3D Bach data is used a lot in the Netherlands. As you can see here some numbers. So per month, on average, it's downloaded 100,000 times for the tiles, and we have 850,000 web service queries per month. And here you see some of the research that we do in our research group on the 3D Bach, so using computational fluid dynamics, solar panel potential, and heating energy demand. But as I said, the 3D Bach is used in many other organizations and companies. So in the Netherlands, it's widely adopted. So we can also say that it passed the research phase. And what is very nice that earlier this year, we received an innovation subsidy from the cadastre for a major software refactoring. And this made it possible to clean up the code and to do restructuring of the code to upgrade the software from a research character that has a research character into a more production-ready version of the software. And this allows to make it easier to maintain the software and also to run easier new releases and to do further innovations on the 3D Bach. And also to let other developers use this software. This refactoring has been performed by 3DGI and TU Delft, the research group, so the maintainers of the 3D Bach. And the improved software components are available via the repository that you see here. And they are also the starting point of this developers meeting of today. And currently, we are looking for a more stable role of the data and the software. Because it's beyond the research phase. And at the same time, we would like to keep the innovation power of 3D Bach and also align it with the 3D base data set that the cadastre is currently providing. And this is why we started the 3D Bach Innovation Platform. And here you see also the logos again that I showed you on the first slide. So the 7 organizations led by Geonovum, they either use the 3D Bach or they have another interest in future-proof 3D Bach. So therefore, we started this collaboration to secure the future of the 3D Bach and to keep the data and the updates available, and also to make it possible to run new releases every year, but also to maintain the underlying open source software, just to make sure that it can be used in the future, but also to make sure that we can still further work on innovations for the 3D-Bug software. And we would like to do this in collaboration, because what we see is that different users have different wishes for the future development of 3D-Bug. But if we align these, then we can join forces and also align the user needs of the 3D-Bug and work on innovations that serve several users. With this collaboration, we also explore the long-term role of the 3D-Bug in the national spatial data infrastructure landscape in the Netherlands. And so there's also ongoing discussions on looking at the current state of 3D-Bug, how that can have a more stable position in the SDI. So the activities that we are doing in this year with this collaboration is that we started a community of 3D-Bug data users. And here you see a picture of a session that we had in October in the city of Amsterdam. And here different users of 3D-Bug presented how they use the 3D data. And they gave very nice examples of their use of the 3D data. And also they shared with us their wishes that they have for future developments. And another activity that we would like to do in this year is to start a community of software users and developers. And that is actually the aim of the meeting today. So this is the first meeting to establish a developers community for the 3D-Bug. And we do this in English because we see that it's not only of interest for the Dutch community to use the software, but with other input data sources, it's also possible to use the software to reconstruct areas outside of the Netherlands in 3D, and also to contribute to the software. Because the open source character of the software is a very important part of the software. And we are very happy that you're with so many here, so that shows a lot of potential for future contributors. And another activity that we will do under the umbrella of the 3D-Bug Innovation Platform collaboration is that we are working on a new version of the 3D-Bug based on the latest version of AHN. It's the AHN 5, version 5. But as you can see in this picture, it's not available for all of the Netherlands yet. The red areas are not available for AHN 5, so the new release will only have the green and blue areas in the new release. So today's meeting, the goal of the today's meeting is to start a developers community. And we will present the key components of the 3D-Bug software and also share with you the plans in the roadmap. We would like to hear your ideas and feedback for future developments, and discuss the possible structure and the organization of the developers community. So this is also new for us, and we will also learn from this meeting how to proceed. See if we can agree on a work process and a communication platform, and also on having meetings periodical meetings with developers. The target audience of this meeting is firstly the potential users of the 3D-Bug software, so not per se the contributors. That's the second type of target audience, so the developers that actually contribute to the software itself. But we also see people that use the software, and we think that it's also useful to involve them in this community. And as I said, we do not only aim for the Netherlands, but we would welcome very much the contribution from outside. So with that I would like to give you a global overview of this meeting. If you already have questions, you can share them in the chat, and then we will see if we can answer them during the next presentation. In a few minutes or seconds, I will give the floor to the next presenter, and then we'll give an overview of the different parts of the 3D software. And the aim is to show you how you can build your own 3D bug. And then we have a 5 minutes break, and then the second part is dedicated to the 3D bug data access and the processing, and this part will be more for the developers who actually have an aim to contribute to the 3D bug software. Then there's another 5-minute break, and then we would like to close with an open discussion on the roadmap and on the community building for the 3D bug. Yeah, so I would like to repeat, put your questions in the chat so that we can answer them as much as possible. And first, we would like to know a bit more about your background. So this time for some questions. So I give the floor to Gina, I think.
Yes, indeed. Can you please stop sharing your screen so I can also... Thank you. You cannot see my screen yet.
I think we can.
Just give me a moment. You can?
Yes, but not full slide.
Oh, just give me a moment. I'll manage. Can you see this? No, right?
Oh, yes,
No.
we can.
Yeah, we see
Okay.
they're getting to know you. Yeah.
Amazing. Okay, so I'm Gina Stavropoulou. I'm one of the developers of the 3D bug from the TU Delft side. And yeah, it's quite exciting to see so many people interested in what we're doing. I see already 64 people here. So we would like not only like to show you things, but we would also like to know a few things about you. And in order to do this in a little bit more effective way and a little bit more interactive, we're using a Mentimeter. So the way that this works is that you will need either your phone or a browser. With your phone, you can scan this QR code in order to join the online quiz, let's say. Otherwise, you can use your browser and join at menti.com and use this code in order, again, to join the quiz. So I see already a lot of people joining. I will wait a little bit more so that everybody can join. I hope that everybody can join. Oh. Yeah, I think that I can probably, I don't know if everybody is already on the Mentimeter, but I will go to the first question. You're still able to join at whichever moment you want through this. So the first question is, which country are you from? You can, yeah, just focus on answering on your phone or on your browser, and then you see the results on my screen. Nice. As expected, a lot of people from the Netherlands in different ways. Okay, nice. Nice. Okay, France, Belgium, Indonesia, Turkey. Wow, a lot of places. Nice. We have around 44. Okay, I will wait a little bit more because there are a lot of 20 more people maybe that they want to participate. Cool. All right. Next question. Which sector are you working in? By education, we mean universities, just to differentiate a little bit from private and public. We want to see who is mostly in universities. All right, nice. Okay, most people are from public sector and private. Okay. Next, do you have any previous experience with the 3D bug data or software? And your option is like yes with the data, yes with the software, yes with both, or none. Just for us to see a little bit what is the experience of our audience. Yeah, I was kind of expecting that most would be experienced with the data at least. Okay. Then next question, do you see yourself as a potential to debug software user, developer, or nothing? Mm-hmm. Nice. It's very nice to see that actually a lot of people see themselves as potential developers. Almost as many as users. Okay, that's good. Yeah, that was the first feedback question session. There will be another one at the end because we want to gather a little bit of feedback about this workshop. So this was a kind of a training session. So I will switch back to the presentation. Yes. Slideshow. So we did this, and then we're moving on to the first part of the workshop, which will be about building your own 3D bag. And I will start by giving you a very short overview of the 3D bag tools. So we recently gathered all our code and all our tools under a single GitHub organization, the 3D bag organization, which you can find in this link. And under this organization, you can find multiple repos, which are serving many different purposes for generating the 3D bag. But yeah, of course, you can find all the information here, but just to make the overview a little bit more clear, there is CityBuff, which is still in an experimental stage, but it's basically a new encoding for CityJSON based on flat buffers. Then GeoDepot and its API, it's still in development stage, and it's a test management system for geographical data. Then we have 3D bag pipeline and Roofer. These are maybe the most important repositories that we have because these are the ones that are used for generating the 3D bag and producing each new release. And then finally, we have 3D bag API, the dashboard, the docs, and the viewer, which are tools that are used for publishing, for disseminating, for visualizing, and of course, for documenting anything related to 3D bag. As you can imagine, producing the 3D bag is a quite complex process, and it involves a lot of different technologies. So I wanted to show you a little bit, like a very quick overview of all the technologies that are being used. Of course, the list is not exhaustive, but yeah, just to give you an idea. First of all, regarding the programming languages, we are most of our code is in Python, in C++, and Rust. And of course, we're keeping our data in a Postgres database, and we're also using PostGIS. We're also using a lot of libraries that are external and they are related to geographical data like LastTools, Seagull, PDAL, GDAL, and GEOS. I'm quite sure that most of you will be familiar with those. Regarding the formats, of course, we're using point clouds in LAS format. We're offering the data in geo packages and CityJSON, but also OBJ and a lot of other formats. And we will talk more about the formats in a later part of this workshop. And then finally, we're using all kinds of different technologies for different parts of the production. Daxter is the backbone of the pipeline. GeoServer is used for the WFS and WMS layers, and OpenAPI is used for our 3D bag API. Yeah, that's it from me for now, and I will give the floor to Ravi, who will give you a more in-depth overview of Roofer.
Yes, thank you, Gina.
Yes.
So I'll talk a little bit about Roofer.
Should I stop sharing or not? Okay.
No, I think it should be okay. So what is Roofer? Roofer is the application that we made to do large-scale automatic LOD2 building reconstruction. So it's basically, that is the piece of software that does the actual generation of the 3D models from point clouds and building footprints. But it's not only an application. With the refactor of this summer, we also made an API available in both Python and C++. So just to give you some visual clue of what it does. So a Roofer takes basically for one building, it takes a point cloud, which is typically an airborne LiDAR, and a roof print polygon. We assume that these are well aligned, and then if we have those two data sets, we can fully automatically generate 3D models with detailed roof geometry, like the one that you see here. And this is so-called level of detail 2, which means that the roofs have a high level of detail. So Roofer does this, and in this process, it tries to have a very accurate reconstruction. So that means that the final building model should be close to the input point cloud, but at the same time, we want to have like very compact models, so that they have like a low number of faces, so that they have a small file size, and they're easy to use and to disseminate. And like I said, this happens fully automatically. So we do this automatically for the whole of the Netherlands with the 3D Bach. But that's really the goal of Roofer. So the core Roofer is the actual building reconstruction algorithm. I will not go into detail today, but it involves detecting planes and lines in the point cloud and then constructing from those basic features the final mesh models. But Roofer also does some other tasks like quality assessment. So we care a lot about quality of the building models. So there are different phases of Roofer. There are quality assessments. We look at the input point cloud. We look at the final building model and how does it compare to the input point cloud, and also the actual validity of the geometries that we produce can also be checked with Roofer. And of course, one major focus with Roofer was to handle large areas. Then a little bit about the history of our building reconstruction algorithm. So originally, and some of you, I think, will know it as the GeoFlow software. So originally, this building reconstruction algorithm was developed as a plugin to a software called GeoFlow. And GeoFlow was basically a research slash algorithm development tool for 3D geodata. So it's a very generic tool. It mixes like low-level building blocks, like just code, but this kind of higher-level flowchart idea that you can use these building blocks to build algorithms to process geodata. And this was very useful during the development of the reconstruction algorithm, because we could test different approaches in this setting, and that worked quite well. But it also has some limitations, and this basically is something that we discovered as the 3D Bach as a data set grew, and we started to do reconstructions for the whole country. Basically, GeoFlow itself, the software, was also a prototype, and it was never really designed for production use. So it made it difficult to do reconstructions for large areas and to like maintain that software. So if we wanted to do a large-scale reconstruction, we actually needed also external tools to work alongside Roofer to manage the reconstruction. And well, the bottom line is that we made this work, and we could do reconstructions for the whole country. But over time, the software grew like brittle, and we had to do several hacks to work around limitations, like fundamental limitations with the GeoFlow design. And yeah, this turned out to be this increasing complexity was kind of a problem for long-term maintenance and development. So over this summer, we developed Roofer, which is basically takes the building reconstruction part out of GeoFlow and builds it into its own dedicated application. So what were the kind of the goals with this new Roofer application is to do large-scale building reconstruction in a reliable way, so that we guarantee that each input feature also results in one output feature, which was not always the case with Roofer. And we do not have like silent failures, so buildings that are not reconstructed and you never hear about it in using the software. And there was a big focus on the usability, and in the sense that we really tried to minimize any kind of pre-processing that is needed. So previously we had to like manually pre-tile the input data and then run different instances of GeoFlow in parallel, but externally managed, which was a bit of a hassle. So with Roofer, this is all built into the software itself. So you can simply point it to some large data that you have, and you can just let it run without any pre-processing needs. And then we focused on also like proper validation of the input data and arguments that are given, and good error reporting. Another focus was the like really efficient large-scale reconstruction, and it means mainly that we now have multi-threading built into the Roofer application to do the building reconstruction quickly. And also we looked at the memory efficiency, so that you can in theory run like a very massive data set, like for instance an entire country with one Roofer instance. And finally, we really try to have a simple design so that it's easy to maintain, and also to minimize like external software dependencies. So quickly, the Roofer architecture and overview. So if you look at the software, there are basically two parts, which is the core, and this is the core reconstruction algorithm. And for that, we use mainly Seagull, and there are no other software dependencies there. And then we have an extra module, we call it, and this is it contains the extra machinery for the Roofer application. So this is to manage large-scale data mainly, and also to do the input and output handling. So the core is basically what is in the Roofer API. So this if you want to use the reconstruction algorithm in your own software. And then we have the Roofer application, which encompasses both modules of the Roofer software. So then the processing pipeline in Roofer. So in the input, we have the input data, which is point clouds and roof prints of the buildings. First, there's a kind of a filter step, and this allows you to select a spatial subset of your input, even if you have like a very large input database somewhere. We can simply plug it into Roofer, and using this filter option, we can select a subset spatially or based on the roof print attributes. The next step is to tile the input, so that happens internally in the Roofer software. And currently we just use a simple regular grid for that. And then for each tile, we process the buildings. So the first step in this process then is the cropping, which means that we basically cut the input point cloud into small pieces, one for each building, so that we have for each building a small point cloud and its footprint. And then for each building, we do the actual reconstruction and the serialization. So that means writing it to a file. So the second part of the pipeline is happening asynchronously, which means that it happens, basically these three different phases happen at the same time when you run the program. The reconstruct step is multi-threaded. So because this is where most of the computational power is needed, this is what where we implemented multi-threading at the moment. And the serialization happens, so that's writing the building models to disk using the CityJSON sequence format. And one of the reasons why we selected this format is that this allows us to write a building to disk as soon as it's ready, as soon as the reconstruction is finished. So we do not have to wait for a whole tile to finish or for the whole program to finish before we can write data to the disk. Then, so just to give you some idea about this asynchronous function of roofers. So like I said, this means that all the different steps in the pipeline happen at the same time. And basically this is what you see in this plot here. You can see in the different colors, the different pipeline steps. And on the vertical axis, we have the number of buildings that is produced. And you can see that all the steps, they are working at the same time to come to finish the processing. And also on the bottom part, we see the memory footprint. And this was a big goal to make sure that Roofer doesn't run out of memory when you process large data sets. And you can see that the memory use is pretty stable over time. So how do you use Roofer? Well, like I said, there are two main ways. You can use the API if you're a developer and you want to integrate it into your own software. Or you can use the application, which is probably what most people will use. And this offers also additional functionalities for handling large data sets. So very quickly, so how can you use Roofer through the Python API? This is like the important lines that you need in your Python script. We have a configuration that you can change some reconstruction parameters. And then the reconstruction itself is available as a single function, which returns you the building meshes. Then the C++ API, it is similar, basically the same idea, but then for C++. And we have one first user of the C++ API, and that is a software called City for CFD. So that is computational fluid dynamics for the urban environment. And this is first software where Roofer is used through the API. Then how do you use the command line application? So currently Roofer is only available through the command line. And the goal really is to enable like efficient reconstruction of large areas with many buildings. So how do you use it? It's basically the most simple way to use is simply to call the Roofer executable with an input point cloud and an input dataset with your roof prints, and then specify an output folder where the CityJSON sequence files will be written. And this should work as long as your point cloud is classified, of course. There are some requirements on the inputs, but basically this is the simplest way to use Roofer at this moment. But you can also use larger input data sets, like for instance, instead of only using like one point cloud file, one loss file, you can also point Roofer to a directory with a lot of loss files. And then it will scan the directory for the loss files and use those. You can also connect to, instead of a geopackage file, you can connect directly to a PostGIS database to get to your roof prints. So this is the input handling, and this could be country-wide data sets. So we can actually run this with all of the data that we have for the Netherlands. And what we are currently using a lot is this subset feature of Roofer that I also mentioned. briefly before. So this is the functionality to spatially filter a subset from the input, and then we only do the building restriction for that subset. So it can be either spatially using a bounding box query, or based on the roof print attributes that you have in your data. But in theory, and this is not something that we are actively doing yet, but this is definitely the vision, is that we can also simply use Roofer for the whole country. We simply have our data ready in a directory in a database, and we launch Roofer, and it should work for the whole country. This is not currently extensively tested, but this is the vision that we're working towards. And basically all the foundational building blocks are ready for that. But there are still some small issues that we need to solve to make that possible. So what is the current status? We're nearly done with, let's say, releasing a first stable version of Roofer, like 95% done. Documentation is already available online, and we have on our GitHub, we have a develop branch that you can use. And because we do test things before we push to this branch. So yeah, you can already try the software if you are willing. Then a few words about the future plans and the roadmap. So basically, before we release version 1 of Roofer, we have the upcoming 3D Bug data release that Jan-Tien mentioned earlier today. And we will use Roofer for the production of this, and no doubt we will find some issues during this process, and we will fix these before we release version 1. So this should happen like later this year. And there are a few other small things, including like building automatically binaries, and also making the Python bindings pip installable. So this should happen this year. Then what's after this first version, we have other plans to implement multi-threading also for different steps in the pipeline, to offer more tiling options, because now we only have like a very basic regular grid tiling. Yeah, some other options. So we are also thinking about building a graphical user interface for Roofer on top of the command line interface. But before we do this, of course, we want to have the basis done and working well. And then, yeah, CityBuff was mentioned earlier and will be mentioned later today as well. We will probably add this as an output format next to CityJSON sequences. Then there are also some, let's say, trivial improvements that we can do to improve the quality of the building models. So this should happen like fairly quickly after we release version 1. And this involves like improving the plane detection in the reconstruction algorithm, and also on the output side of the building meshes to remove these coplanar faces that you sometimes see. We want to merge these so that in the final building model you will have fewer faces, but the geometry is pretty much exactly the same. Then a bit of a longer term vision. What other ideas do we have for future Roofer? Yeah, one is to reduce the reliance on accurate building roof prints, because we realized that even though in the Netherlands we have very accurate building roof prints that fit well with the LiDAR data, this is not everywhere that readily available. So we want to reliance on this accuracy in the roof prints, the alignment with the point cloud. And there are also other building reconstruction methods that we are aware of, and I think it's good that we look at those, and maybe we can incorporate some good ideas so those algorithms into Roofer. And especially we're thinking about improving the regularization in the geometry, because sometimes currently the reconstruction result shows some small irregularities, depending also on the input data, of course. But this is definitely something that has our attention. And finally, This is probably the most difficult to implement, but there are some developments going on currently in enhancing like input elevation data, so the point cloud using deep learning methods to smartly fill in occlusions in the point cloud and to filter out any vegetation that might still be hanging over buildings. So I think this is very interesting, but this is more of a research project than something that we can immediately implement. Yeah, so that's it for the roadmap. I hope you find that interesting and you're encouraged to try the software. You can find it on our GitHub. And then I would like to answer some questions that came into the chat. So maybe Balázs, if you can tell me.
Yes, I was also trying to answer what
if there's anything left
was there. But yes, for instance, there was a question: how does Roofer create a mapping between the directory of last files and the input polygons in the database?
The mapping between those two.
Yes.
So basically, we assume that the inputs are in the same coordinate system, and that's how it's aligned, because it's in the same coordinate system. So this is basically how we do it.
Then, following the coordinate system question, Emmanuel had a question: what's the situation with the CRS handling in Roofer currently? Is it possible to use it with any other CRS than the Dutch one?
Yes. Yeah, that's a good question. So in Roofer, there were sometimes some things that were semi-hard coded. This is no longer the case with Roofer. So we removed any kind of default options to, for instance, the Dutch coordinate system. So actually, the coordinate system handling has been simplified a lot. So previously, GeoFlow it did also some internal conversion between different coordinate systems, and this is no longer the case in Roofer. So it is not very picky about the input coordinate system anymore, but we do assume that that all the data is in the same system, and it will detect from the metadata which coordinate system it is, and then it will also put that in the output files. So yeah, that's the answer.
Okay, thank you. Then Teresa had a question: what is an ideal point cloud density to work with, and also does it also work well with higher point cloud densities?
Yeah, so for the Dutch data, we work with the point cloud density of, let's say, 10 points per square meter. Actually depends on the area a bit. Some areas are a bit denser, and this works well. So basically what we have done so far is between the 10 and the 20 points per square meter. Yeah, there are a few considerations. Like, first of all, the detail that you will get from your reconstruction is higher with higher point densities, obviously, because the smallest feature that you can detect depends on like how many points are needed to detect a plane in the point cloud. And this is currently the default value is about 15 points. So if you have, let's say, 15 points per square meter point density, that means roughly that the smallest features that you will be able to detect would be like 1 square meter. So if you increase the point density, you can have more details in your models, but at the same time, it will also increase the computation time. And this is not a linear increase, it's more like a quadratic increase. So if you have like a very dense point cloud of 50 points per square meter, I might want to, I would probably reduce the point density a bit. So yes.
Then, thank you. Another interesting question.
Balázs is gone, I think.
Yes.
Yeah, Balázs, you're breaking up.
About prints.
Oh yeah, there you are. You're back again.
Yeah, can you please repeat that, Balázs?
Sorry, my
Sorry, no, it's not working.
Are roof prints mandatory or still?
Yes, roof prints are still mandatory at this moment.
Maybe
And
I
there are no.
sorry, because maybe I'm created confusion because I mentioned Bach footprints because that's the common term that we use in the Netherlands for the Bach, but the Bach actually does not contain the footprints, but the projected outlines of the building. So that's maybe good to be aware of. It's not the footprint in the Bach.
Yeah, a more accurate term is the roof prints. Yeah. So I think that's it then. So right.
I think there are still quite some questions, so I'm going to, in case you can hear me still.
Yes, I can.
Yes. So what was your process for tweaking parameters in your algorithm and then testing the results for 10 million buildings?
Well, basically so mostly the algorithm tweaking depends on the point cloud data that you're using and the characteristics of that data. So we tweaked parameters as we developed the algorithm, and we developed it using the Dutch data. So we already had like a pretty good idea of what would work. And then we run it for larger areas. And if we see that something is not right somewhere, we look at a specific building and, load it into the software and visualize what's happening. And then based on that, adjust the parameters. But of course, you have to be careful that you don't over optimize the parameters for just one single building, because then it might negatively affect others. But so there's a trade-off there, but this is roughly the process that we use.
Okay, and then another question from Hakim, I think. So, are there any experiments point cloud sampled from photogrammetric meshes?
Yes, we do have some experiments. We've done some tests with that, and well, long story short is that Roofer was really developed on LiDAR data, and LiDAR point clouds has like some different characteristics than like these dense matching point clouds from photogrammetry. And mainly is that these dense image matching meshes, or point clouds, they are typically like overly smoothed from what in our experience. So the restriction wouldn't always work as well. But it's a bit hit or miss. So it depends really on the quality of your photogrammetric data. But so far, our experience is that we get more accurate results and more regular results with LiDAR point clouds.
Okay, then a question from Nicolas about the development experience of the new Roofer compared to GeoFlow. So is there significant changes from a developer's point of view between GeoFlow and Roofer in terms of compilation, external resources?
But it should be easier to compile Roofer. Like we put quite some effort also into.
Should we?
Sorry, Belos.
Yeah, I'm sorry. So yes, please go on with the answer.
So we put quite some effort into improving the build process. So we use, for instance, a VC package to manage all the dependencies. And this basically means that you only need to call CMake, and it will automatically download and compile the dependencies. This may take a while on the first try, but after that it should be pretty smooth. So I think this is improved in terms of like the developer experience. Of course, if you start to transition like your data workflow to Roofer, you might need to change some arguments, and some parameter names have changed. But from a developer's point of view, it should be smoother. So okay, I can see the next question. So where's the conversion from CityJSON to 3D tiles performed? This happens in the 3D Bach pipeline. So this is part of Balazs' presentation, like how long does the whole pipeline take for the whole country? I mean, it requires currently still some manual steps, but I think it's like 1 week for the whole country. But the building reconstruction itself is like approximately like 48 hours, 40 to 48 hours. And there's actually a lot of time lost in simply data conversions, more than the reconstruction itself. So yeah, I think that's it for the questions. So I think then Balázs, I give the floor to you.
If he's
Is
still
Balázs
there.
still there?
Yeah.
Okay.
Sorry, I'm trying to fix my connection problems.
Well, maybe I can start the presentation, and when you're ready, you can take over. Or are you ready?
Yeah, I should be ready in case
Okay.
you can hear me.
Yeah, we can hear you. So please
Okay.
share your screen and.
All right. Let me quickly find where I am. Where I am. Here I am. And I will share my screen as well. I believe you should be seeing 3debug pipeline on the slide right now.
Yes, thank
Correct.
you.
Yes. So thank you. That's what I'm going to talk about in the following minutes, provided that I can switch the slides. Yes. So what is it? The 3debug pipeline. It is the code or the tool that generates that sources the input data that we use, preprocesses the data that we use, then runs the actual reconstruction, which Ravi just talked about. Then it does some format conversion, validation of the reconstructed models, and packaging of our output formats, and then finally it deploys the results onto our server. And what you see in this screen is an overview of the whole pipeline in the Dexter user interface, because the 3debug pipeline is implemented using the Dexter framework, or data orchestration tool, to say it nicely, which is an open source project with a very permissive license. Has been around since a few years, although I would still consider it a relatively recent project. There is a company behind it. It is in very active development, sometimes maybe too active development, because they change things in their API relatively frequently. So sometimes it's a bit hard to catch up actually with the latest changes. But basically, it is written in Python, and what to use Dexter means that we need to write regular Python code, like regular Python functions, and decorate with some Dexter-specific decorators and constructs on the top of our functions. So it uses concepts like assets, jobs, resources, and runs, where assets would be, for instance, a database table that needs to be generated. For instance, the point cloud, would be the point cloud files. Does not necessarily need to be a database table, but can be a point cloud files on disk. That would be an asset, including all the code that is required to download, to persist those files on the disk. The same way about database tables for vector data and so on. And then jobs would be, let's say, a chain of these assets that we run in a specific topic, for instance, downloading all the point cloud versions for the AGN dataset, or sourcing all the 2D vector input data from the Bach and the top 10 NL. Or and then we have resources which declare computational, we declare tools basically, or directories that we can pass into assets and we can pass into jobs. So for instance, the data directory on our hard disk is a resource in our case, but the Roofer executable, for instance, is also a resource. The database connection is a resource. So the database itself is a resource that are used by the assets and the jobs. And then when we actually materialize or execute an asset, so the computation itself or a job, that is called a run. So in Dexter, we create runs, and then we can track the progress of a run. How it progresses. To give you an overview what it actually looks like, so Dexter has this user interface that you can see in your browser. What you see on the screen is the 3debug pipeline, the snapshot of the 3debug pipeline itself. So if you would check out the code and start the pipeline, navigating a little bit, this is what you see, just to have an idea what you can expect. In case you have worked with, in case in the past you have worked with this sort of visual tools, for instance, like what would be FME, if any of you know FME. So this might resemble what you see in FME, but the big difference is that here in the user interface is basically just reporting the status of the code that is running. So I cannot work through the user interface in the same way as FME does. I need to write Python code and then see how the Python code looks like in the user interface. So everything is written in Python. The source data set, so that has been mentioned before, but as again, to summarize, the source data set that we use are three data sets from the Dutch government. The most important one, two most important ones being the Bach and the AGN. The Bach are the building polygons, roof prints. The AGN is this classified point cloud that was acquired through laser scanning. And the top 10 NL, it is another 2D polygon dataset. It's a topographic map. We use that to extract classification on greenhouses. So because it contains classification on the usage of the buildings, including greenhouses, and that's important to us because we use it to filter out large buildings that contain glass roofs, where the point cloud is very problematic for the reconstruction. So those greenhouses go into our reconstruction process, and they do not get a detailed roof model, but they are reconstructed as a simple extrusion. Then I'm going to go through the different jobs, so the different stages in the pipeline and what each thing does. So as a starters, we have the AGN tile index job, which basically downloads the AGN, so the tiling index of the available point cloud files from the AGN. It prepares tables where we store metadata about these metadata that we compute from these point clouds, and we also use checksums. These are unofficial checksums of the LAZ files that we use to control that the multiple gigabyte files that we downloaded is actually the file that exists on the remote server, and if it's not, then we retry the download. Then we have 3 different jobs for the 3 different agent versions, because the latest one that is still under development, that would be the agent 5. So it downloads the LAZ files. We also index the point cloud files using the last index tool from last tools, which creates appends a spatial index into the LAZ file itself, and it is important for the building reconstruction process so that we can efficiently query a region from within the point cloud file directly. Then we compute some metadata on the LAZ files that is there to give us an indication, give us an idea about the quality of the file, in a sense that is this file compromised, or can we read it? Is it an actual usable point cloud file? So these agent jobs, they are partitioned. Partitioning is also a concept that you will find in Dexter. In this case, simply put, it means that there is a separate run per each tile that we have in the agent dataset. So we can track, in this case, we can track exactly which tiles have been completed. So which tiles have been downloaded, indexed, and the metadata computed, or which ones fail, and which ones are missing. As the next step, which is still part of our current pipeline setup, although here I have to say that this is something that we are working on these weeks. Actually, last week, this week, and next week, it is under active development how this exactly going to look like. But for now, we are still using the 200-meter tiles for the point cloud. So that means that we, after downloading the agent tiles, we further chop each loss file into 200-meter by 200-meter pieces. That is to speed up the point cloud reading a little bit. And also in the past, we used it to manage memory usage during the reconstruction. Then we come to the stage where the 2D vector input is handled, plus the preparation of the input dataset for the actual reconstruction. Then, so as I said, we have two vector input datasets. One is the bug and one is top 10 NL. It is a relatively straightforward process. We download it from the government's data server. We load it into a database. So in this case, the vector inputs go into Postgres, and we do some validation, like filtering of duplicate objects. We calculate the overlap between the polygons to also check for duplicates, basically. And we combine them into our reconstruction input table. And we also tile it up further to manage the large scale reconstruction. So we have, as you heard, we have a separate tiling for the point cloud files, and in this case we have a tiling for the polygon inputs as well. Then we go on to the reconstruction, which in this case in Dexter, at least in Dexter, is a single asset. So we have a bunch of tiles, generate a bunch of bunch of polygon tiles coming from the previous steps, and we run Roofer on each of them, and then eventually we get the reconstructed models, reconstructed 3D models as CityJSON files on disk, CityJSON sequence files on disk. Then after that, we have our export process in where we convert these CityJSON sequences into other formats, for instance, the geo package and OBJ, and what was it? And yes, and we combine the CityJSON sequences into CityJSON files or tiles themselves. So there's another tiling process. This is the final one, where we create the tiles that you can then download from our viewer. And then we also have a validation step, or actually evaluation of the reconstruction. So where we calculate from the files that are on disk that came out of the reconstruction. So what is our reconstruction rate? How many buildings did succeed? Or what are the ones that are missing? And then finally, we have a deployment step, which so far is highly specific to our servers, basically. What it does is it creates archives, so it compresses our files. Again, there is another validation step on the compressed files itself, just to make sure that nothing went bad during compression. And then we move, so transfer the files onto our web server, and we load them into GeoServer to make it available for others. So that was the overview of basically what it takes to generate the 3D Bach dataset, at least what we call the core dataset. And on the top of that, this year we have added 2 extensions, and we call it extension that because they are computed from the already generated core dataset. So basically they are adding additional attributes to the already generated 3D building models. We are talking about estimating the number of floors of buildings, and the second one would be computing the party walls in the buildings, and the party walls are the wall surfaces that are shared between 2 adjacent buildings. So the number of floors estimation, according to our evaluation, it's quite accurate up to 5 floors. Above 5 floors is not so much anymore, because simply we did not have enough training data to train the random forest regression models that we use for this estimation. And these are computed, as I said, computed from CityJSON sequence files or CityJSON features. And the party walls are computed from the CityJSON tiles 10. Now comes a little bit of architectural overview. So this image I took from the Dexter documentation, but it applies to the 3D Bach pipeline just as well. So you imagine that Dexter itself, so it is a service. It has 2 main parts. One is a daemon that manages the execution of the runs and jobs that I talked about before. And there is another service, which is the web server, that serves the user interface that I showed you in the screenshots. Now there are so-called code repositories in where we store the code for our packages. In our case, each extension would be a separate package. For instance, the floor estimation, the shared walls, the party walls computation, and the 3D Bach core dataset computation. So they would be in this slide. The green boxes would indicate then our packages, or that we have in the 3D Bach pipeline. The communication, Dexter solves the communication between these code locations and the Dexter web server through gRPC, which I will talk about it a little bit later. And then there is an external database In our case, we also use Postgres for that. That stores execution logs and execution metadata, which helps Dexter to tie everything together. So basically, it records which asset has succeeded, which asset did not succeed. It allows to restart failed jobs very easily. So that would be an overview. And now, when we come to the 3DevOps pipeline itself, the repository itself is a mono repo. So would it be a monolithic or mono something repository, meaning that all the 3DevOps pipeline stuff lives within one Git repository. We have a common, and it's split into multiple Python packages. We have one common package which does not contain actual logic for running the 3DevOps pipeline, but it contains utility functions or the resources that are used by the 3D packages. So the core and the particles and the floor estimation. And each of the three packages, so the core, particles, floor estimation, they are installed in a separate virtual environments because they have very different dependencies, and some of them have a lot of dependencies. And because Dexter communicates through gRPC, that is no problem, and it helps us to avoid conflicting dependencies, which would definitely happen if we would try to install everything into the same environment. But because of gRPC, there's also some limitations of how the different stages can pass, of what the different stages can pass between each other. So for instance, they cannot pass execution results, but only the status that something has succeeded and, or something has failed. But it works so far, and I think this setup helps us much more than actually hinders. So to install the pipeline itself, it is not, so the 3DevOps pipeline is not a software per se that you would install and run from the command line but it contains many parts, as I explained. So the easiest way to deploy it for yourself is using the Docker setup. As I hinted with the Dexter architecture overview, it has many parts, has many services that are running at the same time. So the Docker setup is a multi-container setup. We built Docker images that contain all the tools and has all the dependencies that are required for running the 3DevOps pipeline. And each of the packages, so the core, the particles, and the floor estimation, live in their own Docker image. So if you deploy the 3DevOps pipeline with Docker, then it's going to then you will see a lot of containers starting up, and that's how it's supposed to be. We use this Docker-based deployment ourselves actually for. I cannot say that we use it in production because we haven't produced the latest release yet, but we did produce the first test, or at least development test for one province in the Netherlands, using this Docker-based setup, and we also use this setup in GitHub Actions, where we run our unit tests and integration tests. It is also possible to deploy the pipeline natively, so install stuff directly on your machine. That's how we used to do it in the past, but it is quite complicated because you need to compile all of the tools that we use, and it is a lengthy process. And generally, I would not recommend doing that, although it is possible to do. So in the past, let's say half a year now, we invested a lot in writing documentation for you, basically, and also for ourselves, because as time go by, we forget things. So it is good to remind ourselves how things should be done. And so please go, if you are interested in using the pipeline, please check the documentation. If you don't see anything, or if something is unclear, then do tell us. And if you are interested in contributing in any way, because contribution does not necessarily mean writing code itself, we have a contribution guidelines where we give where we explain how you can get started, essentially. So we do have a roadmap. Use GitHub milestones for that. So we have a bunch of issues and we organize them into milestones. But to give you an overview of what's coming in the next release, and the next release, in case of the pipeline, a release means that we were able to generate a stable 3D bug dataset that is published online. So because the pipeline itself is quite tightly coupled with the 3D bug dataset, our release versioning follows the 3D bug data itself. So as I said, we are still working on integrating the new roofer, although we did the first tests already, but it is not exactly finished yet. We are working on integrating the new AGIAN version into the pipeline. Still, there are a few things that needs to be changed or upgraded for the latest Dexter API. And we are working hard, and we already worked a lot on improving the developer experience, so to speak, so that's actually possible for other people to install the pipeline and use it and even change some things in it. And yes, we still have some way to go in fully automating the pipeline, fully automating parts in the pipeline, and that's what we are planning to finish until basically this month or so, until the end of the year. And that would be my part of the presentation, and I can answer some questions if there are any that is not answered.
Yeah, I think there's one question from Emmanuel. He asks, how easy is it to adapt the 3debug pipeline to datasets other than those used by 3debug? So, for instance, for France.
Yes. So that would mean changing the first part. Let me see. I go back to this overview in the very beginning. So that would mean changing basically these boxes of bug, top10NL, AGIAN, and input. So these 4 stages in the pipeline, because these are specific to the Dutch datasets. So if you want to use it for your datasets, you need to implement the logic that processes your input datasets in some way as you think. We are planning to write guidelines how to do that. Hopefully sooner than later. And then one thing that you need to know, you need to be quite familiar with Dexter to do it, actually. So it is definitely possible. It is some work.
Thank you. That's so part 2 is about data access, and the first presentation will be by Hugo Ledoux from TU Delft about CityJSON.
Thanks, Ravi. We're a bit late, so I will go a bit faster. So if you have questions after that, just ask them in the chat or later at the end. I assume that many of you are familiar, at least to some extent, with CityJSON. But I'm going to speak about new developments that we've done recently. But basically, if we speak about CityJSON, we need to speak about CityGML, which is the international standard from the OGC in 2004 or 2004-06, I'm not sure, to represent 3D city models and also landscape. So it started as a data model and as a XML, GML encoding. So for years, there was one data model with only one encoding, the XML, GML one. And then we at TU Delft, we started CityJSON and we released the first version in 2019 and the second version in 2023. And that's really a work that was done only by me, my colleagues, and some students that were used as guinea pigs in courses. And it grew way bigger than what we expected. Now it's also standardized by the OGC as a community standard, and it's used by many people, and the 3D bar makes use of it. To make a long story short, we decided to have a JSON encoding because we were not really happy with the XML encoding. The files are very, very complex. The tweet there on the right is basically what made me start work on CityJSON, because I also felt the same. I was dealing with files that were always very big, very complex to manipulate, couldn't parse them with JavaScript, couldn't really do anything on the web. So I decided that I was using JSON that was simpler, better. So I decided that, okay, we need to just convert the data model to JSON, which is what we did. And now we're at CityJSON version 2.0, and 97% of features of the complexity GML data model are implemented. There's a lot of software, we'll speak about it in a second. And one nice bit of moving to a JSON encoding was that we can work with files on the web, but also that we compress files by a factor of 7 about, which is not negligible if you're exchanging data on the web. We have developed a lot of software around CityJSON. So if you go to cityjson.org/software, we offer a long list. I don't think it's an exhaustive list. If you develop software and you would like us to add it to the page, you can just go to the page. The source code of cityjson.org is on GitHub also. You can just make a pull request. We're happy to add any software that you have. A lot of the software is open source, I have to say, and a lot of it was developed by students at the TU Delft. So some of the software that you see now was developed maybe 3 years ago by a student, and it's not really been maintained. We're small teams or academics, so we try to maintain some of the software, but we cannot maintain it all. But if you want to do something, the first thing you should do is go to that list and then see if someone has work on that. And then maybe there's old software, but maybe it's easier to just adapt it than starting your own from scratch. We have a viewer which is called Ninja, so maybe you've used it. If you go to ninja.cityjson.org, you can just drag a file, any file, and you can visualize it. That was developed by a mix of MSc students and PhD students at TU Delft, and it's still maintained by a PhD student. Probably the single most important software if you're dealing with CityJSON files is CGIO, which means CityJSON input-output. So it's a kind of a Swiss knife tool that allows you to manipulate, convert, and edit CityJSON files. It's not perfect software. It's basically me and Bala that started it at the end, the last 2 hours of the day. So we've been patching it, but I think it's very useful. So it allows you, for example, to create subset, to merge files, to remove textures, to add attributes, remove attributes, and so on. So it's a simple software written in Python that we are in the process of, we're always in the process of maintaining it and cleaning it, but now we're trying to do a serious attempt at it because we think it's very useful. Many people use it. And we like it because if you deal with bigger files, you don't need to call the call one operator and then save a temporary file to disk and then start from that one. You probably know that if you work with GIS data. So it allows you to basically chain together many operators. So you can say, I have a file, I would like to reproject it to another CRS to create a subset, to compress it and so on. So you can chain all your operators in the same command line. So it's only a command line interface. Notice that there's also an API that Balázs is maintaining. We're not really maintaining the API at the moment. We will work on it in the future. But if you use CJIO as a command line interface program, then I think it works, and we're looking for help also. So if it's useful for you and you want to help us add functions, help us with bugs, you're very much welcome. Yeah, and to use it, it's on Python, so pip install CJIO. But if you're a developer and then you work directly with Python, for example, you can, what we do often is just use the JSON support, which is built in Python. So you can just use very simple code to parse a file. Usually we just use that. For big projects, it's probably not a good idea, but for small projects, we just use Python with the JSON package. We also have something that we developed at TUDelft last year, also student project that now has grown a bit bigger. We have CJDB. So instead of using Postgres and the 3D CityDB that many people use, where there's 80 tables, I think, we developed a very simple data model where you can store a CityJSON file with only a few tables, and there's a Python importer exporter. And this is being used in the 3D bar API that I will show a bit later. SafeFME also has CityJSON support, but it's unfortunately not fully up to date, but the code is open. I'm saying that because we see in the Netherlands, many people use FME. So you can use FME to read and write files, but I think at the moment they still write the old version of the files, only 1.0. We don't control what FME and Safe are doing, but we're hoping that they will update their support, but their support for the older version, and then you can always upgrade your file with CJIO if you want. What I wanted to say is something that Ravi already mentioned twice. It's CityJSON sequences or CityJSON text sequences. That's something that's new that we've developed in the last year about. The problem that we had is that CityJSON files can be very big. So if you go to the PDOK, the Dutch government website, you can download files that are often a gigabyte or more. And so the list, I won't go into details, but CityJSON file keep all the description and the attributes for the geometry, but then has a long list of vertices. And for some of these files, the list could be several million vertices. And as Ravi said, one of the bottleneck of the whole workflow to create 10 million buildings is not the reconstruction algorithm, but I/O, so reading files, passing files to others. Then having big files of CityJSON was a bottleneck. So we decided to look for an alternative solution to create smaller files. And one solution was to use the idea of streaming. So the idea of streaming is to have very small files and to have small files that don't have to be accessed globally. So if you have a data set, then what we do, if you have a data set that has many buildings and trees and so on, we basically take every building in our case, and then we create one data set for each building, and then we process this building separately. It can be used for other applications. This is a slide for something else, but what we did is we created CityJSON sequence. And CityJSON sequence is basically on the left. If you have a file that has 2 buildings, then what we end up is creating 3 JSON objects, metadata to keep everything, and then 1 for each of the building. And then these are pretty small. So one building, at least in the Netherlands, would be a few kilobytes at maximum. So then what we did is that we create one JSON object, for each of the 10 million buildings. And then it allows us to compress the file to process it separately. And also to process things faster. So we develop software that, so we have a converter. So it's called CityJSON. It's open source. It's on the GitHub repository. So you can convert any CityJSON file to a CityJSON sequence file and vice versa. It takes less than 5 seconds for one of the biggest files that we can find, which is 580 megabytes. So basically what it does is it converts the file, but it will also, if we use CityJSON sequence, it will also compress the file. So we found that in practice, files are maybe 15–20% smaller than their original file, even if you duplicate all the information. The reason why, you can ask me later. But the main advantage for us was that instead of processing big files, if we just chunk them into a lot of small files, was the amount of RAM we use. So we just wrote some text, some script here in Python where we take a file and we just iterate over every object and we check what is the type of the geometry. And if you see the RAM use, well, if you use CityJSON, then you would load the whole file in memory. You need to deserialize it. You need to create data structure. So the RAM was pretty big. But if you use CityJSON sequence, then often the files will have something between 10 and 25 megabytes because you're processing every object independently. So the RAM usage stays very low. And also the time that it takes to process a data set was increased by, I don't know, between 1 to 6 times faster. So for us, using CityJSON sequences would improve a lot the processing for the whole pipeline. And the CityJSON sequences is also what you get if you use the 3dbar API. So if you go to api.3dbar.nl, we have since, I don't know, less than a year, the OGC, it's an OGC API. It's almost OGC compliant. And what you get are CityJSON sequences. And the last thing I want to say is, Ravi wasn't happy with CityJSON sequences. He still thought that it could be a bit faster because it's still a text representation. So he started to work last year on a binary representation of CityJSON sequences. And he took inspiration, or he modified the flat GeoBuff, which is a flat buffer from Google. So he started to do some work and called it CityBuff, and it's now on the GitHub group of 3dbar. And we have an MSc student who's starting to work on this. So he will take what's been done, the draft, and expand it and then see what's possible. So in the future, we're hoping to be able to offer something which is a binary and which is faster than what a text-based representation can do. And already with the first test, the binary representation was around 20% smaller, and it was about 2 times faster than the CityJSON sequence. That was it for me. If you need information about the CityJSON and also the CityJSON sequences, if you go to cityjson.org/cityjsonsec, you can see all the development and the specification that we have there, and some the software that we've already converted that can process this format that we think will mostly replace CityJSON. It's CityJSON, but it's smaller, it's faster, and so we're going to update all the code so that it supports sequences. All right, that was me. Thank you.
Okay, next is me. You see my screen. I think you can see my screen now. So now that we saw about CityJSON, I will show you how you can actually get this format and others from the 3dbar. And this is for both for users and for developers. Yes. So the 3dbar is available in various formats. The individual tile formats that we are offering is a GeoPackage, OBJ, and of course CityJSON. And then we also offer the full data set in a GeoPackage, which is around 18 gigabytes zipped and around 100 unzipped. And of course, we also have some web services, WFS and WMS, but also an API which offers 3D data in CityJSON sequence, as Hugo described right before. I will just tell you a little bit more about how you can get these tiles easier, and also a little bit about the API. So starting from the tiles, on our website, you can find this viewer, and then you can click on a tile, which will prompt you to this view, and then you can actually download each of the formats that I mentioned. However, this is very good when you have a specific location that you know where it is, and then you can download the tile. But it's not very useful when you want to download, for example, all the tiles in a certain region, when you want to download all the tiles that cover Den Haag or something like that. So for that reason, we would advise you to use our complete tile index, which is also offered on our website on FlatGeoBuff format. FlatGeoBuff is a cloud optimized encoding, which would allow quick bounding box operations. Our tile index in that format contains the links for it contains the tile IDs and of course the links in its format. And then by accessing that file, you can access those links and download whichever format you want. In order to do that, we also offer a small script. It's a very simple script. It downloads the tile index, and then by putting here the bounding box coordinates, then you can download the tiles that you want. It's a little bit more complicated than that, but you can find it in our 3dbug scripts repository. Then regarding the API, it's a very good way in order to gain access programmatically to 3dbug data, and especially when you want a single building or a small area smaller than a tile. It returns CityJSON sequence format, and it allows not only the retrieval of a single building, but also like bounding box operations. It is not OGC compliant yet, and this is because right now the only supported coordinate system is the 3D Amersfoort. I just want to tell you a little bit about how you can structure your URL requests. So using our endpoint, you can use the Bach identifier in order to request a single building, or you can use the bounding box with x min, y min, x max, y max in order to retrieve all the buildings within that bounding box. You can have more extensive instructions in our API documentation. However, when you are requesting a single building, what you're getting on your browser is this. These are all the attributes that are contained within a building. However, this is not very intuitive. Like you might be wondering, what can I do with this, or how can I visualize the actual model? So in order to help with this situation, we also offer a small script. The script extracts the CityJSON sequence file from your browser, and then it automatically converts it to CityJSON. And then CityJSON can be easily viewed in a viewer as Azul or as Ninja that Hugo mentioned before. And again, this script is in the 3dbug scripts repository on GitHub. And just to to close, we are also planning to offer a new format, IFC. IFC is a format which is usually used in BIM software, and this will be available not in the upcoming release, but probably the release after that. And in order to make this available, we're also developing a converter between CityJSON and IFC. So I hope that you heard something interesting in all this. Now we're moving on to our next and last part about the roadmap and community.
Yes.
Yeah.
I'm going to take over as soon as I share my screen again. Now we are speeding up the the presentations a little bit because we are running out of time. So let me, yes. See my screen, roadmap. One slide over what is coming in the next upcoming 3debug data version. That would happen some point in a month, let's say early December. I don't know. I think we are still quite well on our way to actually make that happen. As Jantin mentioned in the very beginning, the Adrian 5, so the last version of the available point cloud dataset will be integrated in the pipeline. So not only the pipeline, but the 3debug data as well. Part of that process is to research how actually good is this new point cloud version for building reconstruction. So that is work that needs to be done because, for instance, in the previous versions, switching from version 3 to version 4, we noticed that the newer version, Agent 4, did not really live up to the expectations in some areas that we had. So we are very curious what this latest version is going to bring. And the second main thing is to use all these improved tools that we just talked about in production. So this will be the first time that we use all of the upgraded refactor tools in production. So that's always a bit scary because we always discover errors that we haven't seen before. So yes, these are the two things. After the release now, in the beginning of the next year, let's say, I don't know, first semester, whenever the next version is coming up afterwards, we're going to add the IFC as a file format for downloading. That work has started already on the conversion into the IFC format. There is a long overdue update for the 3D viewer that you see on the 3debug website. So we need to update the library that visualizes the 3D model so that can use let's say the latest 3D tiles, so the 3D tiles version 1.1, because the software that we wrote last year that converts to 3D tiles, that would convert the CityJSON sequences to 3D tiles, that generates 3D tiles version 1.1, but our current 3D viewer only can visualize 3D tiles version 1.0. So there's a bit of conflict there, but we plan to resolve that. And the work on Roofer, so the building reconstruction, that is a continuous, never-ending process. Let's say we're going to work on that too. So that's about it. A small sneak preview. So the most obvious changes that the latest point cloud version will bring is that there are areas that are not available in the current point cloud version. So these are very newly constructed, very new developments. Of course, these will appear in the new data release. And so far, what we have seen, the results are actually quite good. But we need to see it also. We need to evaluate for a larger area. So that was about the roadmap for the data itself, so for what is coming. And now a small few words on how actually we plan to communicate with you, 3debug software, 3debug developers. We have this GitHub organization. So that would be, let's say, the main point of contact or the main point of entry where you will find everything that we do. So please visit that regularly to see if there are changes. That is where you will find also the repositories that that we are working on. And yes, so all of the software that you see there is open source. It has all of them have relatively permissive licenses, so you can use them. And we are planning, or we have a public communication forums. I will get to that after this these slides. And we are working on, we already written quite some guidelines on how to contribute to different repositories and different softwares, but we are still going to write more to make it easier for other people, I mean, outside of the current group of developers to do any sort of contribution to the 3D bug. Let it be code, or let it be providing ideas, or finding errors, or writing documentation, or fixing the documentation, or anything of that sort. So as I hinted, there are many different ways that you could contribute. So you can just simply use the 3D bug data, but report how it goes, please, because we need to know what not only what you find problematic, because by now we heard a lot about that, but we would also like to know what you find good in it. That's always nice to hear some positive feedback. If you do use the software, also definitely tell us how it goes, because yes, we would like to have some again feedback, or loop back to, is it actually useful for you, or if it's, or you try to use it and you find that it's not usable, then why did you stop using it? Why is it not useful for you? You can work through or look, so we have quite a long documentation on the 3D bug data itself. It's on how to use different formats, descriptions of the attributes, and so you could contribute to that by reading the docs and extending it with parts that you think are missing, or fixing the parts that you think are not clear. The same way, if you read through the documentation of any of the software and you think that there's something missing, or it is not clear to you how to actually get started, and if you do take the time to figure things out with our help, then it is very welcome if you write those things down and submit as a pull request. Same as with writing and fixing things in the code, in the source code of the software. And of course, if you spread the word about the 3D bug as a project, the data or the software, that is always very, very good for us to raise the awareness inside the Netherlands and also internationally. Finally, as Jantin mentioned in the beginning also, the 3D bug, let's say, project is undergoing changes in a way, and we are looking for sponsors, so the sponsors to provide a stable future for the 3D bug. And in case you are ready or interested in being one of the sponsors, then do contact us. I guess if you contact any of us, we can take those takes that further. Yes, if you do want to contribute in any of the software repositories, we do have contributor guidelines per repository, so please check there for the repository that you are interested in. Then how do we plan to communicate? So we have a newsletter. You can subscribe using this QR code, or there's that link where it is a passive way of communication, but this is, let's say, if you do subscribe, we use this as to notify everyone about upcoming about an upcoming release, what's going to be in the upcoming release. For instance, we did notify people about this event. We will notify people about upcoming events, but it is a very low traffic newsletter, so we're not going to spam you with anything. Basically, you can expect an email every trimester or so, every couple of months. So that would be about that. We did set up a chat, so you can chat with us in Zulip instead of Slack. Sorry, Richard. But if you do, this is a very, very new thing. We just set it up yesterday or day before. So that would be the primary way where how we communicate as developers on the software. We share ideas there. We exchange ideas in this Zulip chat. Then there are, of course, also the issues per repository. So if you are certain that you found a bug, or you would want to request a feature, please open an issue in the repository that is relevant. If you are not sure where to submit your question, or you just have an idea, or if you're not sure that is a bug what you found, then let us know in the chat, and we can take that further. So that would be it, but please do not run away yet, because we still have some questions to ask from you. That would be very important for us to know about your opinions and preferences of how can we take things further. And I would pass on the word to Gina.
All right, I hope that you are ready for another Mentimeter. So just before we move on to our open discussion, we want to collect some feedback from you, but also like some discussion points. So please log into the Mentimeter again, either using the QR code or on your web browser with the menti.com. I mean, I know that was a lot to absorb in this whole workshop, but I hope that you still remember a few things so that you are able to answer the following questions. So we'll start the questionnaire, but you will be able to join at any moment using this information here. It will stay on the top of the screen. So what was the most interesting 3D bug part that you saw today? Was it the automatic building reconstruction and the roofer that was presented by Ravi? Was it the session of how to make your own 3D bug and the 3D bug pipeline? How to disseminate or retrieve data, which was basically the 3D bug API, and then also like that, yeah, it could be that nothing stood out to you, or that was too much information. So yeah, feel free to vote for that one as well. Let's see. The results are ranked, so you can choose multiple, but rank them based on your preference, but also you can choose only one, whatever you prefer. Okay. I think most people prefer the roofer so far. All right. 20 people so far. All right. Okay. I'm moving on to the next question, which is, which 3D bug software do you want to try out? Like after this workshop, will you go home and try one of our software? Is it the roofer? Is it the 3D bug pipeline? Is it the API, or is it none? Yes. Yeah. I'm glad that nobody answered none yet. So, all right, 22 people interested in roof and 23. Nice. Okay, moving on to the next question. Shall we have a regular 3D community meeting, something that happens every now and then so that we can coordinate on the future or on the roadmap? So yeah, our suggestions would be monthly, every 3 months, every 6 months, or maybe you believe that this is not really necessary for you. All right. Nice. So most people believe that it should be every 6 months. Good. Next, is there anything that prevents you right now from using 3D software or that you would like to see improved? This question receives a text answer, so you can type and you can type multiple things. So we will see your responses and then we can also use this later for like developing new things, but also now as discussion points. So please feel free to answer whatever comes to mind. Yeah. Okay. Some people are lacking time. Ease of installation is an issue. Nice. Great. Time and resources, yes. That's quite important if you want to produce, for example, your own 3D bug. I will keep using 3D bug data to speed up my 3D modeling buildings. What to improve quality of the models? Or is it the AHN data software I'm using? I don't know. Okay, and up-to-date Docker images. Okay, that's some nice feedback. Okay, I will move on to the next question. In what ways would you be interested in actively contributing to the 3D bug? You can, again, choose multiple answers, or you can just choose not interested. Oh, nice.
You need more financial support.
Yeah. That's true, but also at least nobody is not interested. Like a lot of people want to contribute.
Also good news.
Yeah. And the final question is again a text one, just again as a discussion points. What should be on the roadmap that is not already there? Like, did you see something missing? Would you like 3D bug to go towards a specific direction? Maybe that's a little bit tricky of a question because maybe you don't actually remember what was on the roadmap, but.
Okay.
I thought so.
Maybe, yeah, think about what could be there that is interesting for you.
Nice. LOD3.
Okay. Okay, images, textures, I see. About the 2D bug data to get more recent data are, how do you say? The bottleneck is unfortunately not the bug, but the point cloud that is available as open data. So the timeliness that depends on the timeliness of the point clouds that we use.
Yeah, exactly. That's exactly what I was thinking, that we need to uncouple Roofer from that data. It would be nice to. Oh, there's more. Nice. Wow. So many
Use case.
answers.
Images again,
Mm-hmm.
updating if GPU. Okay, that's an interesting one. Thanks.
Nice. Okay. I think we have plenty of answers now. So I want to thank you for your feedback. And I think that I will give the floor to Jantien, which can coordinate our last Q&A and our open discussion.
Yeah. Well, it's not so easy. So yeah, we are with quite a large number, and yeah, the aim of this meeting is to start a developers community, and it's nice that we get some ideas from your side. But maybe it's also nice, at least first, to give some time for people who would like to speak up or add comments or add suggestions. So if is there anyone who would like to add anything to all the materials presented? Yes, Tom?
Yeah, first of all, huge congrats on what you have achieved so far. I mean, I've been kind of looking at the sidelines at this work for many years, and I've seen from where you started, and I think this is an impressive set of software running. That being said, I noticed that there is some interest in financials here to deal with the continuation of the software. And sponsoring was in big letters here, but I have the feeling sponsoring is a very difficult word for private companies. They just don't know how to deal with it. So this is not a technical issue at all, of course, but would you be interested in setting up something like a bounty system where you can just like throw money into a certain thing being solved and just send an invoice?
Yes, thank you for this insight from a company. And yeah, we are looking for ways to secure the future of the 3D Bach. And as I said, in the past we were lucky with funding from research institutes, and these insights gives us very important insights into the ways that we can organize this. So thank you for that, Tom, and we will look into this further. It's also new for us. How to do this, but that helps. Other suggestions or comments?
Or maybe questions that were not answered before in the chat.
Yes, Tom.
One more then. For the past hour, I've been also trying to get Roofer running on my system. I kind of got it working. I just can't get the configuration file working. I'm just curious if anyone in this list of 100 people, I don't know how many people have managed to run it, like not from Docker, but really build it.
I see a message in the chat that the French people just run it on their data.
That's Tom as well.
Yeah, that was me.
On French data. Oh, you did that. Sorry.
French data. I'm Dutch.
Yeah.
Yeah, but not with the build. So.
Yeah, well, I mean, if we can discuss this maybe in the Zulip chat to fix this issue. I did recently make some changes to how the configuration file is structured, so maybe that's maybe it is a changing thing at the moment. So, but let's talk about it and we can figure it out.
Yeah, and I'm happy to build for people as well. I mean, it doesn't need to be a private session. Just if not people who would be interested in playing with it, maybe some kind of small workshop or something.
Yeah, that's a good suggestion. Thanks.
Yeah, and also via the Mentimeter, we got suggestions how to proceed. Depending on also on the activities and the dynamics, and I think we will decide on how many or if and how many meetings and what kind of meetings, I guess. So it's very useful to get your input for this. So via the Mentimeter, we have not the names who submitted their wishes for sprints, for example, or for it was also shared in the chat, but also for specific contributions. So I can imagine that if there's indeed a serious interest in the contribution, that we have other meetings than if there's an interest in mainly using the software, if people have questions how to use the software. So in the meantime, I also look at the messages shared in the chat. Yeah, so yeah, I'm also looking at the other 3D Bug team members, but I think
Yeah.
Yeah.
I can say something. So people are complaining about building roofer. I have updated the documentation like yesterday, so maybe you should check the latest documentation. And if you still have issues, I would say join the chat and we can discuss these issues and solve them.
I see a last message. There will be an interest in a workshop on how to get started. So originally the idea for this current developers event was to have a small thing with a smaller amount of people, let's say, but then it spiraled out of control. And we see that with 50, 60 participants, we cannot really have a smaller session where we can actually discuss ideas in detail. So we had an idea the last days that we might have another smaller session with a smaller group, or maybe multiple smaller groups. We don't know yet. Let's say still before the end of the year. Please do subscribe to the Zulip chat or the newsletter so we can let you know when we plan something and how can you register and how that you are interested, and so that we can organize this. I just posted the links to both the chat and the newsletter in the chat, in this Teams chat again, so you know where to find things. In case you don't find anything, you can always visit the main 3D Bug website, which I'm also going to put the link right here. You can visit the 3D Bug website directly and navigate there, and you will find all the information for sure, and links to the GitHub, links to the Zulip chats, links to the newsletters to find your way around.
Yeah, and this the start of this developers community is part of a huger development for 3D Bug, and that I explained at the start, which we are looking for a way to secure the future of the 3D Bug. So that is also to do with maintaining the software, but also with the innovation of the software, and that is so this meeting is part of that initiative, to establish a 3D Bug innovation platform, and also with the 7 organizations involved in that 3D Bug innovation platform, all governmental organizations, we will see how to continue from here. Also, I know that all those organizations have also developers themselves interested in joining. So I think also with them we will see how to organize and to get this started. So yeah, I don't know if there's more to say at this moment, but otherwise I think we can close up, or